In this lesson, students are expected to generate and record equivalent fractions using a variety of manipulatives and describe when and why two fractions are equivalent. For this lesson, students have been using manipulatives or math tools to explore and identify fractions. Here are some of the tools they have been using: fraction circles, pattern blocks, Cuisenaire rods, geoboards, and fraction strips. Let's use pattern blocks to show and explain fractional equivalence. We'll begin with a yellow hexagon as our whole. This hexagon is equal to 1. I can represent this one using 6 green equilateral triangles. The student may write an equation in their journal to explain that 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 equals 6/6 or 1. They can place the hexagon on top of the triangles to physically confirm their equivalence. Using other blocks, the student will discover that 2 red trapezoids are also equal to the 1 hexagon and therefore equal to 6 triangles, and record 2 halves equals 1 and 2 halves equals 6/6. The trapezoid represents 1/2 of the whole, and therefore they may record 1/2 plus 1/2 equals 2 halves or 1. They could also cover the triangles to note that 1 trapezoid is equal to 3 triangles and record the observation mathematically: 1/2 is equal to 3/6. Sometimes the whole is represented as more than one piece. We could state that 3 yellow hexagons equal 1 whole. We could ask the student to express the value of 1/2 of this whole. One way would be to cover 1/2 of each hexagon with a trapezoid, because we know that a trapezoid is half of a hexagon, and then see that 3 trapezoids are half of 3 hexagons. If we look at this now, we can see or count 6 partitioned pieces and note that 3 of 6 equals 1/2 of our whole, and record 3/6 equals 1/2. In this lesson, we have asked the student to use manipulatives and visual models to make sense of fractions and identify and label equivalents and fractional pieces. We know that a student is successful when she or he is able to accurately model, label, and explain their thinking when representing fractions.